So welcome back, Level 3 NCEA Physicists, continuing on with the electrical systems external. Today we're looking at Ohm's law and resistance. Okay, so remembering back what potential actually is, potential energy is essentially energy which is stored. Okay, so in terms of voltage, it's essentially the potential difference between 2 points in a circuit. Therefore, voltage is PD, or the potential difference. Its symbol is V, and its units are also V, or volts. So looking at the example there, which battery has more voltage, the 1.5 volts or the 9 volts, it will be the 9 volts. So going back to the previous lesson, as a review, Kirchhoff's first law, basically the total current coming into a junction must equal the total current coming out. And those are the two examples that we used, being careful, of course, to recognize that the direction also changes, and that's +4, not +5. So we also have Kirchhoff's second law, which is based primarily around a voltage. Okay, so the sum of the voltages, the potential differences provided, must equal the voltages across the components. So the sum of the voltages in a loop, when you're working anti-clockwise, so from negative to positive, conventional current will be equal to 0. Therefore, the voltage on the left will be 4 volts, and the voltage on the right will be 2 volts. Why is this? Okay, using our example here, so it'll be -8 plus 12 minus 4 equals 0. For the example on the left, and for the example on the right, it will be +12 plus -9 plus -1 plus -2, which will equal 0, because when it's going negative to positive, it's positive, and when it's going positive to negative, it will be negative. And over resistors, it'll always be negative. So then we move on to resistance. Okay, so essentially resistance is how difficult it is for electrons to flow in a circuit. Its symbol is R, and the units are a funny little symbol called the ohm. Okay, and which one has more resistance for water flow? It would be the hose, because it's a lot thinner, or in terms of its the width compared to a giant pipeline. And in terms of relating that to conductors and insulators, so the conductor being the key and the insulators being the rubber ducky, okay, conductors have a very low resistance because they're essentially made primarily out of metals, okay, which are that free-flowing C electrons around the positive nucleus of the metallic atoms, whereas the rubber ducky is consisting more of covalent bonds, which hold on to those electrons. There's less free electrons, so it has that high resistance. And resistance in a circuit, so all these components will provide a certain amount of resistance, and you have to be, of course, remembering all of them through the power of Kung Fu components. So in summary, in terms of electrical properties, we have the voltage, which is the potential difference. Its symbol is capital V. Its units are volts, which also has a symbol or unit of V. Current is the rate or flow of the charges moving through a wire. Its symbol is I, capital I. Amps, capital A, are the unit. And resistance is how hard it is for current to flow through a conductor. Its symbol is the capital R, and its units are the ohms. So how are these going to be related? Okay, so as voltage goes up, resistance is remaining constant. The current will go up, so voltage is proportional to current in a circuit. And as resistance goes up, the current will go down if the voltage is the same. So resistance is proportional to the inverse of the current, 1/I. And that's kind of an image to kind of illustrate that point there. Voltage providing the force for the current to move through, and the ohm trying to kind of squeeze it and stop the amps from moving, or the charge from moving. So Ohm's law, remember that, so it's V equals IR, okay, you can rearrange it to I equals V over R, or the resistance equals the voltage over the current, V over I. In terms of graphing Ohm's law, a linear relationship means that Ohm's law is obeyed, and it means that your component is an ohmic resistor because the resistance is going to be constant. It's going to be the gradient. And the higher the gradient, the lower the resistance, and the lower the gradient, the higher the resistance. We also have non-ohmic resistors like incandescent lights, because the filament actually heats up and the resistance increases. Okay, those are examples there of 3 different components which are non-ohmic. Filament lamps, thermistors, and semiconducting diodes, which we'll look at in more detail in the rest of the course. And these are components which are non-ohmic. So in terms of graphing Ohm's law, looking across the 2 amps, you can see the voltage for X component is going to be 4 volts. So therefore the resistance will be 4 divided by 2, or 2 ohms. For the non-ohmic component, you can do the same from the graph. It'll be 2 amps, it'll be 10 volts this time. Therefore 10 divided by 2 will be 5 ohms for the resistance for that non-ohmic conductor. So you can combine resistances in 2 ways, either series or parallel. Okay, and you can kind of use that as an example there of a straw. So you can basically what you do is you're blowing the capacity of your lungs through either a whole straw, 2/3 of a straw, 1/3 of a straw, 2 short straws, or 3 short straws. And what you'll see is that the time to exhale over time reduces as you go from a whole straw to 3 short straws. So a whole straw will be 3 resistors in series, 2/3 will be 2 resistors in series, 1/3 of a straw will be 1 resistor, and for the parallel circuits it will be your 2 short straws close together, and your 3 short straws will be your 3 resistors in parallel. Okay, which means that it shows that as you add more resistors in series, the resistance will increase, and as you add more resistances in parallel, the overall resistance will decrease. Okay, so when combining resistors, this is the following equation for series circuits. R1 plus R2 plus R3, etc. will equal the total resistance. Okay, just adding them up, the sum. Whereas it's a little bit more complicated for parallel resistors. So 1 over the total resistance will equal 1 over R1 plus 1 over R2 plus 1 over R3, etc., etc. Okay, so R total will equal R1, the inverse of R1 plus the inverse of R2, added together. Take the inverse of that again, and that will give you the total resistance. And that is pretty much all you need to know about resistors.